Hello, everyone. Welcome to episode 47 of the Day Zero podcast. Before we get into our topics, I will recommend you guys check out our discussion video we posted last week. Talks about fuzzing, some of the benefits and downsides that come with it, and where it's worth it or maybe not worth it when it comes to the types of targets you use it on. So that's on our YouTube, which is where you can also find our past episodes of this podcast. That being out of the way, in this episode, we'll be touching on some Google initiatives and programs they've opened up, the BLURtooth attacks, exploitation of anti-cheats, and some other various research and exploits. So we'll start off with Google initiatives. So the Google Android Partner Initiative was a vulnerability initiative was launched. APVI is their short term for it, adding to their growing list of like 3 or 4 letter terms. So this was launched on October 2nd. They state the goal here is to drive remediation and provide transparency to users about issues in device OEMs that are Android partners. So think of like Samsung, Huawei, Oppo, stuff like that. Um, Now, there have been a few issues discovered in various devices that have already went public through this program, which is kind of what I wanted to shout out here a little bit, and what I found the most interesting. So I'll bring that up here. There's not a ton on here. Most of them are, a bit old. They're from like early 2020, late 2019. But if you want to look at some of the issues that have been found in various devices, it could be a useful resource for you. I like looking at like these bug forums and stuff like that. Um, so Google has had the Android Security Rewards program for a while, but that was all Android open source project, right? It was all AOSP. So where this is notable is this is extending out towards the partner OEMs. So that's kind of what's notable there. Now, Z, I know this wasn't as exciting as you were expecting.
No, I mean it's still definitely a good move, but I mean this is basically Google saying, "Hey, we're testing the OEMs, we're doing this testing. Here are issues, all of that." It's a good move, positive. It's putting it out there. At the same time, just when I initially read that, I was kind of hoping that it was going to be for like vulnerability researchers to find issues on the Android partners or on those third-party devices, and Google would be paying out perhaps a smaller bounty on those, depending on what you found. Basically, just trying to prop up the security of the entire ecosystem. Which I mean, they're still doing with this, but opening it up to everyone.
Yeah. So I think the more exciting, kind of Google announcement was the second one, which is their announcement of the Fuzzilli Research Grant Program. So this is a research grant program, which is also being provided through Google. So here they're offering funding for research into fuzzing JavaScript engines. Now, what's important to mention here is they say today we are announcing a new 50,000 US dollar pilot program to foster research into JavaScript engine, but that $50,000 is Google Compute Engine credit grants. They're not, it's not like they're just sending you $5,000, because they're sending it out in rewards up to $5,000 for the research, right?
Yeah,
So
so it doesn't seem like there's going to be a lot of these grants given out. Obviously, if they're dealing with a $50,000 pilot, possibly rewarding up to $5,000. I mean, at least the max payout, that's only going to be 5,000. Or sorry, that's only going to be 10 people, or
yeah,
10 researchers, 10 groups, whatever. That said, they do say it's a pilot program, so perhaps we will see that open up in the future, which I don't know. It does remind me of what is it? The Chrome Fuzzer program. I'm not sure how familiar you are with that, but
I'm not at all actually. This is the
yeah.
first
So
time
with the Chrome
hearing of it.
Fuzzer program, then basically what happens is you build a fuzzer. You have to build it off of libfuzzer or working directly with clusterfuzz. That's basically what's running with it. Um, but if you add a fuzzer that works on that, finds some new bug, you get paid for all the bugs that the fuzzer finds, but it's Google running it. So you're not paying for any of that runtime, but you still get paid when it finds a bug that Google themselves would not have found. They do have this 48-hour buffer point where if one of their fuzzers finds it first, or finds it after yours, but within 48 hours, then you don't get paid out on it, and there's a $1,000 bonus on top of every bug that it finds. So kind of reminds
Oh
me
wow.
about that because you're kind of getting that free testing time. In this case, with this new program, you kind of get to manage how you use that. With the Chrome Fuzzer program, and obviously the Chrome Fuzzer program is fuzzing Chrome specifically. Whereas this one's the JS engine specifically, so you have a little bit more room with the other program, but no, I mean, it's definitely a good move. I'd like to see it open up more, but obviously they've got to see that this will work and actually giving researchers just kind of that open grant on even just the compute engine. I could see that backfiring too. So, the restriction makes sense here at first, and I definitely hope it opens up.
So they have an overview of the types of issues that, or the types of areas that they find the most interesting. So like new feedback metrics, new code mutation and generation techniques, stuff like that. This program will run for 1 year from October 1st, 2020 to October 1st, 2021. Um, but what's notable about this program too is what you were saying about it opening up more, right? Some of Google's other programs, they're only for like university affiliates, where this is open to everyone. Now, what you were saying with the max payouts and there only being the potential for 10 spots if you're only considering the max payouts, I think that kind of makes sense in the way that I don't know how many people out there are really doing like novel fuzzing research and would be willing to, contribute it to a program like this. So that's where I kind of think that I think it's reasonable, especially for a pilot, kind of like what you were saying there.
Yeah, I don't know.
Um,
I've actually been a little bit surprised by how frequently I do run into people just kind of doing like random little fuzzing research. Like I was just talking to somebody randomly on Discord the other day. Wasn't even a security related Discord, and turns out they were like working on their own fuzzer based on a paper that came out, like some modifications to a paper that came out just a few months ago, just out of the blue. So I don't know. I think there might be more people kind of getting into that side of fuzzer development than is expected.
yeah, yeah. I mean, we've seen a lot of fuzzing papers, but a lot of that comes out of academia, and I don't know how much those types of people will be interested in a program like this. I guess it'd be kind of interesting to see because I imagine we will be able to see the research that's submitted after like a certain point, hopefully. Now,
Yeah, well, they encourage that the researchers, so obviously researchers, if they find any bugs, they are able to claim the CVs, and they get the full payout. Like Google isn't trying to claim any of that. I don't think you mentioned that yet. They do encourage the researchers to do the 90-day vulnerability disclosure policy that Project Zero follows.
and they have to be reported to the vendor. They can't be. I mean, to be fair, I don't know how they would really know if you were hiding vulnerabilities from the vendor, but
But if it
probably not
came
something you should
out,
test.
yeah.
Yeah, Google's usually not a company you want to start with stuff like that. So,
They
you
definitely
know,
have some high-powered lawyers behind them.
yeah. So there are some restrictions on this grant if you go through with it, but it might be some of some interest to some out there. So GitHub, they launched their code scanning, um, their built-in static analysis tool. So they announced this on September 30th. It's designed for secure development and integrates with continuous integration. It's powered by CodeQL, which we've talked about before. I know Z thought CodeQL back when we talked about it looked pretty promising.
Yeah, that was actually almost pretty much like a year ago. I think it was during November that we talked about
I was
it.
gonna say it
But
sounded. I
it's
remember it being the end of the year last year.
like, yeah, it's definitely right around this time. Might have actually been right around this, like more directly than I'm thinking, but I think it was in November. But yeah, like CodeQL is definitely interesting to me. Um, it kind of tackles one of the biggest issues I've always had using static source analyzers is frankly a lot of them suck. Tons of false positives, tons of issues that you don't really care about. Now, if you've got the time to set it up, really tweak it, and kind of get it looking and train it a little bit on your code base, like you can get good results out of a static analyzer. But that takes a lot of time, so it's really only going to be done, in-house development or something like that. Like that team. Whereas when I'm coming in just to do a 3-week assessment, I don't have the time to do that. So what I like with CodeQL is in this case, actually, with basically what they've done is they've opened up, they have a GitHub. Of course, it's GitHub, so they have a GitHub repo containing over 2,000 CodeQL queries that you can run against your code base, kind of being a static source analyzer, but with this community contributed queries. So my interest with CodeQL, though, is just using it more as an augmentation to kind of help with kind of querying code. I have picked up CodeQL a little bit since we talked about it. The biggest problem with it is an absolute pain to learn. They have this little tutorial thing, but definitely not sufficient. But yeah, so they've opened it up. I'm still excited to kind of see how CodeQL is picking up. I mean, Mozilla's added their bounty for it. I don't think GitHub's paying for any of the submitted ones, but like there's a lot of promise with this because it does kind of enable that variant analysis where you find one bug, write a query, and you can find that same bug in several other pieces of code. It definitely does take some effort to kind of get set up on your own code. If you're using a framework, it's maybe not so bad, but you do have to tell like what your inputs are and where they're going and things like that. It can map out some of that automatically, especially again if you are using frameworked calls. Then kind of other people have done that work, but you do have to put in a bit of legwork to get CodeQL working.
Yeah, I think it looks really cool, especially with how tightly integrated it is with like pull requests and flowing with GitHub Actions smoothly. Now, I will mention it's only free for public repos. It's not free for private repos. You have to have GitHub Enterprise. So this is just another one of those pushes to try to push more people towards open source, right? Like there's a few other static analyzers that do the exact same thing. You have to include like a header in the like a comment header in the file for it to be checked. Mira actually uses something like that. I forget the name of the static analyzer, unfortunately, but it's not uncommon to see that with static analyzers where it's only free for open source. I wanted to kind of sidetrack off this though and just say like it seems like GitHub has been doing a lot of cool stuff since Microsoft has kind of came in and taken it over, right? I mean, GitHub Actions was a really awesome recent addition for continuous integration. Previously, you had to use third-party stuff, which was it was a bit annoying to set up, and they also had like it could get pricey depending on the platform you were looking at. Where GitHub Actions is kind of built in. All you have to do is set up the YAML files, which you can just copy from a template. And now you have the code scanning as well. Like it just seems like GitHub is really making a lot of progress in terms of making it a really nice platform to put your project on, whereas GitLab has been kind of stagnant for a while. I can't really think of much that GitLab has done in the last while compared to GitHub.
Yeah, I'm not prepared to get into the like comparison there, but I mean,
No, it's just something I wanted to quickly touch on.
There's definitely been kind of the warnings though with Microsoft, the embrace, extend, extinguish saying, back from, I want to say that's dated to like late 90s, but I couldn't actually date when that came from, but there is that concern with GitHub. I do feel like it's generally been a positive thing since they've acquired GitHub. I know there was a lot of concern right around it, a lot of people moving off to other platforms, and reasonable concern at that. But at this point, I haven't really seen a lot of negative.
Yeah, it seems like it's mostly, a lot of good has come to GitHub in the last year or two.
Yeah.
At least
We'll
in my
see what
opinion.
happens though going forward. That said, seeing CodeQL coming out again, gaining more prominence. Like I said before, I'm excited about CodeQL. I wish it were easier to learn because I still have to figure out how to do a lot of things with it. But at least there's folks on, like, I don't think it's going to disappear anytime soon. And just on the aspect of free, or on using it, I guess I should say, I will say I do recommend using the Visual Studio Code extension or just using the CLI directly over trying to use they have this online interface, what is it, LGTM or something like that. It works. The online interface actually is kind of nice for some things, but it's also quite slow compared to just running it on your own machine.
Yeah, regarding CodeQL, I think that could be a gap that needs to be filled, and maybe we could fill at some point. Once we're more familiar with CodeQL, I haven't really looked at it, but I could start looking at it. And maybe we can do some content around that because it does seem like it's something that you can use to build very powerful tools when you understand it.
Yeah, I
So
think there's a lot of room to use it, like I kind of said before, to augment. One of the issues I had with the static source analyzers was they just give you, like, they're just kind of trained on, they know these issues and that's all they find, whereas CodeQL is just kind of extendable. If, like, what one thing I have used it is just on a large code base, I've just used it to pull out constants that are behind, like, a bunch of macros. Just writing a quick query for that. Now, that's a fairly simple query since it doesn't require you doing any sort of control flow querying. So that's at least straightforward to do, but like, it's just expandable, extensible into what you need to use it for. It's just another query language, except you're querying code, which is a unique perspective on it.
I never even thought of using CodeQL in that context, by the way. That sounds really awesome because that is one thing I hate with auditing C code is just the macro hell. When you're looking at like 7 layers of macros, I didn't really know it was that easy to do that in CodeQL. So now I want to look at it earlier than I otherwise would have. So thanks for bringing that up, to be honest. So, with that being said, though, we'll move into research. So, our first research topic is about finding vulnerabilities and building a profile on exploit authors for exploits used in malware. So, in this case, they dive in on a specific exploit author, and they noted like the kinds of techniques they use to attribute, various exploits in the wild to the same author. So, in this specific case, the exploit authors were not the same as the authors for the malware itself, which kind of makes sense. Writing malware is quite different from writing exploits. So usually, that those tasks are divvied up, I would think. I mean, that'd be a question that would be better for Anti, but obviously he's not with us today. Maybe we could ask him off stream and bring it up the next
No,
episode
I
or something.
mean,
But
that is the case, though. I mean, you've got the malware developers, and malware development in a large way is somewhat similar to just software development. You're just doing more malicious things that other developers might shy away from.
and employing more
I
like
mean,
obfuscation and
yeah,
stuff like that.
there are going to be a few of those things, but like I said, then the exploit developer gets that foothold, and then they don't really do any of that other development. Like, I believe it's fairly rare to kind of have it all in one, like one person doing everything. Partially just, I mean, comes down to like the exploits do take a lot of time. So it makes sense if you're going to be doing malware to split up that work.
Yeah, it's
That's it.
just more feasible.
I found this to be quite an interesting read. I don't think there's any point in going into all the details from it, but they do talk about how they went from fingerprinting just the binary, finding like certain strings in it, looking for commonalities with other files, looking at like, the hard-coded values, like what values did they choose as their garbage values? Were they all A's, or their example is just hex 11223344? But just looking at things like that and how they combine it, and some of the things that they looked for were interesting. One of the things they talk about is like the API that the exploit developer would provide in their exploit for the malware developers to use. And the one case here, this first case that they look at, you would always just use a function called, I want to say it was called elevate, might have been called escalate. Took a PID and it would escalate whatever that PID is up to system and return true or false. Simple API, but it was just interesting about the work that goes into having that interoperation that gets offered by the brokers so that anybody else can implement conveniently and consistently with any of the exploits being sold to them. So I did find that interesting. Also interesting was just the fact that they had, I think they looked at 10 CVs from this author that they traced to this author. Half of them were Ode, and then half of them were Ende.
A lot of
Just
them were also in Win32k, which is not super surprising. Win32k is kind of, let's say, just not awesome when it comes to code quality. But yeah, that's just something I wanted to throw in there.
yeah, fair. I didn't. I'll be honest. I actually kind of skipped over some of this and just got to the summary. I like the colors.
Yeah. Um, Going back to what you were saying about, fingerprinting based on the API that's exposed. I mean, it's something you don't really think about, but it really makes a lot of sense just because, if you're writing a lot of exploits and you're selling them, you don't want to rewrite everything if you don't have to, right? Those kinds of areas where, your privilege escalation primitives and stuff like that, usually you just like copy and paste those or you put them in like a header or something and just call into
Yeah,
them because
that
it's
was
just so
another.
much easier.
That was another thing they had mentioned were some of those common functions. So from crypto implementations to, like you're saying, some of that common code is another thing they use for fingerprinting. Kind of how they did like the syscall wrappers, which matters a bit more on Windows than on Linux. But preferred leak techniques or escalation methods, spraying, all that.
Yeah, so it's definitely some interesting techniques and ones that I hadn't really thought about before, but I can totally see how this would be effective. Exploit authors all have their own styles and quirks and patterns and ways they like doing things. And it doesn't really make sense from their perspective to rewrite it for no apparent reason. That being said, if fingerprinting becomes more of a concern for them, I could see why they would rewrite it or maybe write a script to try to obfuscate it, I guess. But yeah, I mean, it's just not something that people really think about, and it's one of those intelligence areas where one person's trash, I guess, could be another person's treasure in a way. Things that you don't care about, other people can, and that's this research post is just kind of a testament to that. Did you have anything to add on that one, C?
No, no, I think we kind of hit it. I just thought it was, interesting information, kind of relevant, kind of just a cool read.
Yeah. So, Firefox. So this one's kind of a quickie research topic. The issue the article author tries to solve in this article is the fact that they had an XSS inside of HTTP headers through a get parameter, but they had it in a redirect page, so a 302. Problem is, most browsers don't typically parse the HTML body in a redirect page. They just parse the header because that makes sense. If you're redirecting, why bother parsing the body? So here they did some what they call fuzzing. I think more accurately, brute forcing is a better term for that.
Yeah, or just enumeration. I will
Yeah,
mention there, just on the issue, while it starts off with the kind of get parameter, the key thing here is that they're getting a injection in the header, so a CRLF injection in the location header. So it takes whatever they provide in that get parameter, it gets tossed into the location header, which is now completely under attacker control, including the ability to inject new lines, which is fairly uncommon these days. But with that ability to inject new lines, inject a blank line, and you can start writing the body. So that's how they get XSS, but they technically control all of the header. Well, all of the headers after the location header also. So there's kind of that aspect of it, and it is in this case, because of that 302, as Spectre was saying, it is kind of a tricky thing to exploit because browsers just are kind of ignoring the body. They're saying they kind of there are some old tricks like using a mail to address. They talk about a few kind of prior work things, like a mail to address. The one example there with //x :1/ apparently worked also. Not entirely sure why that one would have worked, but
that one seems
basically,
odd. Not sure what
yeah,
that is.
it's a local network path. I'm just not sure why that one would have worked. Anyhow, what I kind of go on to say though is just, or as you were saying, they enumerated all of those different protocol specifications or schemas or schemes, whatever. They just enumerate the list from IANA and found two that worked. Basically, the two WebSockets, WS and WSS. Using those in Firefox only, it would still render the body. So it's just a trick, I guess, to be aware of. It is nice that they were able to get some to work. 'Cause I have definitely been in this situation before and did not have something that worked. It didn't matter a ton. I was still able to show like, hey, there's this issue here. Clearly, you're going to go and fix it. I just didn't spend enough time to go figure out a proof of concept on it. So that's kind of readily available. Just something to be aware of. And they do mention a couple things in there. Using an empty location header will work for Chrome, and using a resource // URI will work in Firefox 81.
Yeah, it's cool they kind of had that, community, contribution, and they added those in there. So it's kind of all centralized for if you want, a few tricks if one doesn't work, or, if you're hitting Chrome instead of Firefox, for example. I do kind of wonder, like, I do have that curiosity itch, I guess, with why WebSockets forces the HTML to get parsed when it otherwise wouldn't. But I don't really know enough about WebSockets to be able to explain that, unfortunately. I know I don't think you really do too much with WebSockets either, so
I
that might be
use them
something
pretty
that,
frequently, but exactly why Firefox would in this case with on a 302 still just it doesn't quite make sense. Like, if I had to make a guess, it would be that they just added some code onto like all of those schemes to say, oh, we're in a 302, don't execute the body. Like, just adding some there. So WebSockets are kind of newer. So it could have been, added after they did that and just forgotten about. That said, that is complete speculation.
yeah, it could be just something that slipped through the cracks, so to speak. So AWS. So another area where the cloud stuff is generally not my forte, but this article goes into exploiting fine-grained AWS IAM permissions for total cloud compromise. So IAM is identity and access management, which is a pretty complex subsystem with how it works with like policies and stuff like that. The author actually links to a separate post they did, which dives more into the background, which you need to like fully understand the issue here, which is why I don't think we're going to go super deep into it. But their research started from compromising an exposed, unauthenticated resource manager service on a Hadoop instance. So this post is quite long. They do go into technical details of some of the issues they found. But what it boils down to is how fine-grained permissions can be used to compromise security by using unsuspecting permissions to bypass block permissions. And I think one quote that sums it up really well, let me just bring it up here. So, but granular permissions are a double-edged sword. You have a lot more ways of doing things than what a lazy sysadmin might think, and we can take advantage of this. So just that idea of, using one permission to get around another one. So I know you kind of wanted to talk about this, Z, when it came to like fine-grained permissions and, you know, what your like general thoughts are on the security of them.
Yeah, well, I want to get into that. I do figure we should give a little bit of an overview as to what happened here in particular. I mean, you've done a bit, but adding on to that, they compromised the Hadoop server, as was already mentioned. From there, next step, they found an IAM key. Found that in this core site XML. Enumerate everything, see what it has. Doesn't have a ton. Couldn't escalate from it. And they talk about some of the tools they're using for this also. Some they wrote themselves, some are pre-existing. But as Spectre was saying, like, they might have permission to do one thing and not the other. So one point that they keep coming back onto is the fact they could list all of the S3 buckets, but they couldn't read most of them. And just through digging around, they managed to find they could read 4 out of the 130 they could read. One of them had another core site.xml, which they were able to get more credentials from, worked from there, did the exact same thing again, enumerated what it had, tried to privilege escalate. And that's where another one of those issues came in with having kind of access to something, access to 2 different areas that gave them the information. So while they couldn't, and they used kind of an interesting method here to do their final escalation involving EC2, effectively executing EC2, having the permission to run an instance and to pass a rule to it. So they were able to they walked through themselves kind of finding this admin role they want to pass to it. And then they can use, they can reference the metadata, hijack kind of the instance role. I don't want to get into kind of how all the roles work, like Spectre was saying. Like, IAM is quite a complicated thing. I will shout out their article, though, their previous blog post here. It's mentioned at the top. I'll add a link in for it. It's a good summary. A lot of it is very similar to what's written in like the AWS docs, but I feel like they were a little bit more concise here. Actually, it was better than I was expecting it to be. So that link's in chat, or it'll be in the description. But yeah, so basically they would find ways. I'm trying to remember what the case was specifically for this one. They were able to. They wanted to find a role that they could use with this EC2 instance. They had to do a little bit with the networking, so that's where some of these roles and different policies mattered. I don't want to jump to that, but they couldn't just query the rules, but they did have permission to list all the rules. So they just did their filtering kind of on the local side, because fine-grained permissions, they could list, they just couldn't actually query or get a specific role and get the information from that. I kind of butchered that explanation. This is one of those things where there's just a lot going on. But effectively, you have the permission for one side, or have permission that lets you, list everything, but not actually access the full details. You can kind of use that listing to get around and get the information that you need out of the listing, instead of being able to do the direct query, which is kind of coming back on the issue with fine-grained permissions. It's really hard to get right. It's really hard to think of everything that you need to hide. And developers are more likely to kind of sit there and be like, well, let's just add this permission because I want it right now and we must need it.
Yeah, when it comes to fine-grained permissions, what I kind of thought about in my head is comparing it to fine-grained locking. In the way that it provides a benefit, for fine-grained locking, it provides performance. In this case, it's more about the convenience, like you were saying, just being able to do something when you need to do it. But it has downsides, right? It's hard to keep track of the state of everything. There's too many things to manage. It's easy for things to slip through the cracks. And, in the case of races, I'd say the best approach is just use coarse-grained locking and then only use fine-grained when you're absolutely sure it's a bottleneck and needs optimization. And I feel like with permissions, I'd say I'd have probably a similar kind of solution that I'd want to, put in place. Create coarse-grained permissions and then fine-tune them if and when necessary. Now, I will say I don't do sysadmin with AWS, and it seems like with AWS, policies are either completely managed or they're customer managed. And the customer managed seems to be, fine-grained by default. It doesn't really look like there were like permission groups. I could be wrong on that, but it didn't seem like there were from like the bit of digging I did.
Well, so there are groups. So you have permissions. Permissions get assigned to entities. And then entities are things that can be assigned permissions. So users, groups, and roles, they all exist. So you can create roles. Roles in particular are users can assume roles. And then groups are just a collection of users, and users, of course, they can just be assigned the permissions directly, but all of those can be assigned permissions. When it comes to the AWS managed policies, it's just kind of like common roles that they kind of expect people to need and use. Yeah, and as outer chat from regex generator, a policy defines a permission, and it's the policy that's assigned over to the user, role, entities, all of that. Basically, it's in my opinion a lot more complex than you'd want it to be. Now, in fairness, AWS, of course, they kind of need to meet everybody's needs. So you can kind of create a much more simplistic role-based access system out of this. Most developers, though, kind of like a lot of the permissions kind of get figured out just on the fly. Oh, I need this right now, therefore I add this permission, just kind of know that's being used, and that's where I think the issue comes. If you have just those few rules that get used or something like that, it's a lot easier to audit after the fact. And they actually mention, I think it's in this post. There's a part 2 to this post also, which focuses more on the escalation aspect. I believe it's in part 1 where they actually mentioned that their structure was just kind of crazy and all. I think they say messed up as the structure for how they did their policies and stuff. So, and another thing that's worth knowing is like even the resources. Then, you have permissions assigned to them through the policies, which are resource specific. Which is where I was touching on earlier about how you can get the EC2 instance in Hijack. So if the EC2 instance has a permission or has a policy on it, it has the resource permission, whatever it's called. If the EC2 instance has that, then a local user on that EC2 instance can make a request to or it can get access to the temporary credentials that's using by calling the metadata service, assuming it's not using the more like metadata service v2, which is more protected. But it could make a call to get those credentials, get the temporary credentials that the EC2 instance has, and use those themselves. So an attacker can escalate if the EC2 instance has better privileges than the actual user they're accessing the EC2 instance with has. It's complicated. And it's a lot easier to audit a system if you have the rules very clearly defined.
I think the key thing I took away from this is that classic less is more mantra.
Yeah.
When you get too many permissions piled up like this, like honestly, when you were talking through that and when I was reading through this, I was just thinking like, if I was a sysadmin in this situation, I would be screwed. Like I wouldn't even like you can't expect people to be able to manage this many layers of, things happening. It's just it feels like too much, And
Yeah, I mean
that's where I think they're kind of trying to highlight here.
that's why there definitely are, the specialty rules for people who just know that. Like you can get maybe not certified specifically on AWS or IAM security, but it takes somebody with the internal knowledge here, who's kind of spent the time to get it, and most developers haven't necessarily spent that time.
Yeah. So I think we'll move into our headlining topic, probably the headlining topic of the episode, which is BLURtooth. So more attacks on BLURtooth. This one was technically known about and was in the media in early September, but the white paper and whatnot was just published within the last 2 weeks.
Yeah, and
So
it sounds like there might have been another group that found this also. I don't have all the information on that. I just read that shortly before I kind of came on here. So it's an interesting situation in terms of the timeline. Like I said, it was the BLURtooth special interest group kind of disclosed this back, I want to say on the 9th or 10th. Didn't even tell these guys that reported it about that. And so this is kind of their disclosure, which is a bit more recent.
yeah. So Blur is a set of attacks on BLURtooth's cross-transport key derivation, which can allow attackers to impersonate MITM, create malicious sessions. And that's kind of important because it seems a lot of the media that I saw covering this classified it as just one attack when it's really a group of 4. So this affects all devices that support CTKD. So basically, CTKD supports 2 technologies through cross-transport. So there's BLURtooth Low Energy, which we've talked about a little bit before. In episode 22, we talked about a device that was attacked that used BLE. It was the Kiwi Smart Lock. And BLURtooth Classic, which supports basic rate, enhanced data rate. So most devices support both, and you can find all the technical details of the attack in a white paper. They put their white paper, they pushed it to preprint on Arxiv. I can never pronounce that correctly. But yeah, like I said earlier, Blur is not a single attack. It's 5 issues, 4 attacks. So those issues are kind of key to, how those attacks work, to the point where they even have a table in the white paper that goes into that. Actually, I'm going to bring up the white paper really quick. So, but I know the PDF is a little bit weird since we didn't mirror it, right? But we can scroll to it. So basically, the first issue is in Bluetooth Classic, the master and slave roles aren't fixed. So one party can basically impersonate the master device by sending a pairing request to a trusted device from the untrusted device, where the trusted device is expecting a response, not a request. The second issue is that the Bluetooth specification does not define secure connections have to be supported on both transports or just only on the transport that's being used for pairing. When they looked into it, it seemed it was only being used on the pairing transport, which means the other transport can still be targeted.
Yeah, and that's something that's worth kind of mentioning here with this. One kind of the key consequences of this issue are that you're kind of able to use this to escalate privileges. So if you imagine some system that just use the really simple Bluetooth low energy, I think they call it just works pairing, which no real authentication on it. It's fairly insecure, but it's meant to be used for, low security purposes. So like a read only, like, hey, you have this system that maybe can be controlled over Bluetooth, but it also has another thing that's just like read only, see the statistics. I can't think of a case right now, but some really simple system. But if they also have the proper pairing using the Bluetooth or BREDR, whatever it's called.
Basic rate enhanced data rate, yeah.
Yes, that's the one I'm thinking of. If you use that, it is stronger security. That's where you've got the actual pairing, you enter the pin and all of that. You could basically use that to escalate from your BLE pairing, your insecure one, into the secure pairing and into using all of that. So it's just worth noting that that's one of the main consequences. And kind of as an aside, the name of the site here that we're on with the PDF, the preprints, it's just said archive. It's fairly simple. Just looks weird.
I've always said arxiv, so
it's just archive.
Okay, fair enough. I'll keep that in mind for the future. So some of the other issues are like the long-term pairing key can get overwritten by a second pairing key over a different transport. And then the final issue is normally without CTKD, a device is pairable and optionally discoverable on one transport, whereas with CTKD, the device is pairable and discoverable over BLE even if Bluetooth is used, or Bluetooth Classic is used between the two parties. So these issues combined allow for 4 different attacks. So on page 6, they have a table, I think it's table 2, and they actually summarize which attacks use which issues. So, some of those attacks can allow impersonation. So they actually break those into 2 different attacks, master impersonation and slave impersonation. There's the man in the middle attack, which uses all of the issues mentioned. And then there's the unintended sessions attack, which uses issues 2 and 4. So I think that table is like a really good thing to look at, just to, just a quick ability to associate issues to attacks. So the reasoning behind the name Blur is because it blurs the boundary between Bluetooth and BLE. I thought that was kind of nice, a name that kind of makes sense, not something we always get with these named attacks. So, but yeah, pretty cool set of attacks. It reminded me a lot of another Bluetooth attack we covered, which was Bias, which was in episode 43. In fact, at first, I actually got this confused with that, because it's kind of similar, because that was also an impersonation attack, but that was using legacy secure connections, which, is actually mentioned in one of the issues here. So there's a few similarities between Bias and this attack. So, not too surprising there. So, with that said, we can move to arbitrary code execution in Facebook. So last week we covered Instagram, and this week we're covering Facebook. So, Z, I'll let you dive into this one, because this was kind of a last minute addition that got added in here today.
Yeah, and the issue is reasonably straightforward. Kind of a web issue, even though this is in This is in Facebook for Androids. It's in the Android app. Arbitrary code execution. It's not remote code execution. It's code execution within the app. So kind of local. I mean, you could debate how you want to call it, but it's executing on the client side. Often when we talk about remote code execution, we're talking about the server side, at least with an issue like this. Whereas in this case, it's on the client. So still remote code execution, still arbitrary code execution kind of within the app. So getting on to what the actual issue is, you upload files, you're part of a group on Facebook, you upload files in the app. I've not actually used the app, but apparently you can download files from that group in one of two ways, either using kind of the built-in Android download manager, which in this case is totally fine, no security issues there. At least this issue isn't in the download manager. Or you could use the Files tab, which lets you download the file through there. So what this author noticed is that if you upload a file with a name that kind of contains a directory traversal, so you upload your file intercepted with BLUR, whatever you want there, you gain control and you modify that file name to include your ... When a user downloads that file using the File tab, it will download it and it will do the directory traversal. So it won't download it to where it's supposed to go. It's gonna .. all the way out and go where you want to place. So you can overwrite any file that the Facebook app is able to write to. Using that, you can just overwrite the local library files that the Facebook application is using to gain code execution that way. So fairly straightforward issue, I think. He did get a bounty for this from Facebook of $10,000, which definitely a fair bounty. Although he ends this off basically with a mini, not a huge rant, but he says he was shocked and objected to it and tried to discuss with Facebook, but no way, they say, that amount is fair and they won't be revisiting this decision. It ends it off with, it's up to you to decide before you report your vulnerabilities, vendor, or leaves kind of the question mark there, kind of that little threat. But I don't know, Spectre, what do you think? Is 10,000 fair for this type of issue?
I think it's fair. Like, I was surprised to see that he was surprised about like 10,000 and thinking it was low because, kind of like what you were mentioning there, it is hitting a client side. It's a client side issue. It's hitting the app. It's not a server side code execution. If it was a server side code execution, then 10,000 you could say might be a little low. But like even 10,000, when you're talking about like some of these bounties and stuff, that's by no means like a low amount. Like if you look at some of the stuff we covered on like HackerOne and stuff like that, for example, we're looking at bounties often in like the hundreds of dollars, not the thousands of dollars. So I think it is kind of I don't know if I really agree with, this person thinking that that's like a really low payout or that he got, scammed by Facebook or something.
Yeah, and I guess it's not on this write-up, or unless it's been edited, but he did comment to the Daily Swig. I kind of did, at least left some comments. I won't necessarily say an interview, but left some comments there saying that he expected it to be like $30,000. And I feel like that's a little bit much. As mentioned, like the average for RCs being $30,000. I couldn't find anything. That's something. Maybe somebody else will know this if Facebook lists kind of their rough bounty amounts for different levels of issues. But when I looked at the facebook.com/whitehat, kind of where they list everything, I couldn't find a good listing that just kind of showed their price range like we might see off of Google or on HackerOne. A lot of them will show kind of the common payouts. But he did mention the 30,000, and again, the Daily Swig article mentioned a $35,000 payout, which was for an RCE. And in that case, it was actually an RCE, like on the Facebook server side. So that was worth 35,000, albeit in like 2014. I think payouts have kind of gone up since then a bit.
One thing I do want to add that I think is an important factor as well when it comes to the payout is it's not like this was a zero-click RCE on the client either. This was through like the groups feature and the file tab. You know, you had to the user had to download the file that was uploaded with the directory traversal in the name, which in itself is probably like it's probably a pretty suspicious name, and I don't know how many people are downloading files, through that. So it's not like it's a zero click either. So I think $10,000 is, pretty fair in this case.
Yeah, as I haven't used it, I can't really say if that's the default to use that file tab. Um,
Yeah, I
but
haven't
yeah,
either. So
I don't know. I feel like the 10K is more than fair, just given kind of what we know about it. I mean, it is a fairly simple issue, like I said, code execution, but it's on the client, needs the user interaction, and a fairly high degree of that interaction. I mean, obviously, I do think Facebook does tend to pay out decently in general, so maybe it could have been more, but like I don't think 10K is unfair. I think a lot of people tend to overvalue how much they think their vulnerabilities are worth.
yeah, it's kind of that classic, it's mine. I found it. I love it. I think it's very valuable. It's very easy to have a bias when it comes to your own bugs. I actually remember like a Twitter thread a little while ago that kind of went into that. People thinking that their own bugs were, magnificent and kind of overplaying them. And not to be malicious or anything, just because, it's easy to like stuff that you find. So, yeah. Just I think it's just a bit of the bias slipping through there. So moving into the hacker one segment, we have we actually covered this person last week. I think the same person.
Yeah,
So public and secret API key leaked in JavaScript source.
I felt a little bit bad bringing this one up because I'm not interested in like following this person around and like
We don't want to dogpile the
critiquing.
researcher.
Well, just don't want to hate on them or just saying they're like critiquing everything they do. But this one just kind of came across. I initially didn't notice it was the same person. So last week we talked about some API keys, or we talked about that public key being public. In this case, we've got another case of they found sensitive data, including authentication key written in a publicly accessible JavaScript file. For example, there's this aviary API key and YouTube API key. In this case, it is a little bit different. So one, it is worth noting something like YouTube, if you're for some of the JavaScript API, you provide like the client needs the API key. They're aware of this. It's actually they give you a little warning about some of the risks when you go to create that key. But like there is a key that's specifically for that. I'm not sure if this is that key. I'm not going to go and take this and try and see what I can access or anything. But it seems quite likely that it is. And similarly with Aviary, I didn't know what Aviary was. It's an online like photo editor that you embed on your own website. So again, it seems like the key is probably being used in that same way. JavaScript needs access to it. These keys are intended to be here. So in this case, I mean, I guess the other case was a public key being public, which is generally kind of the point. In this case, again, these keys are kind of meant to be public, but I just figured it was at least worth shouting out. Like not all API keys necessarily need to be kept from the client. Some are created with the intent of client-side use. So kind of being aware when you're filing reports, be like, what's the actual impact? What can somebody do with this key? So that's one point. The other point is this was resolved really weirdly. Or this wasn't resolved, actually. So it's an ODE, whatever. This is just where it seems like a lazy retest. So of course they make the report here September 17th. At Belika saying, so my understanding it's just a badly designed API. No, I wouldn't say that. It's if you have a JavaScript, like there's only so many ways you can implement a JavaScript UI that like runs on the client and still have some sort of API token tracking, like still get people to pay you with it. So like YouTube still has their main API that does a lot more. but using their API with, you know, embedding YouTube on your website, and then doing things like controlling the time bar. I want to say doing some reskinning on it, but I'm like not the CSS reskinning, but like adding buttons onto the YouTube player. That stuff happens in JavaScript on the client side, and it uses this client side API key. So it's a weaker key. It's still like, I mean, there is a poor design, but there isn't a good solution to that if you still want to kind of be able to track and not just have everybody using it for free. But anyway, with this one, they changed it to triage on the 17th, so they've reported that they found this. The stripo, I'm not sure if I'm saying that correctly, their staff, hey, we'll check it out. And then on the 24th, this user went and said, I see this vulnerability has been fixed/patched. Can we disclose now? I checked this morning. This has not been fixed or patched. The only thing that's changed is, if you notice, they said this, the file containing this JavaScript. So this is on a staging website, but file with it is C196. It's a hash.javascript. You know, when you do something, build systems, it compiles all your JavaScript, packs it all up, gives you the hash of the JavaScript file as part of the file name, so you know it's a unique file, automatically injects that into the page, and you're good to go. The only thing that's changed is, instead of it being in the C1965, it's just in another hash, so main dot something else. So had this user gone through the same steps to actually check, or had this vulnerability researcher gone and looked to see what JavaScript file it was loading, they would see the actual same key values even still sitting in there. So they turned around and said the issue's been fixed and patched without really testing it. The only thing they would have tested is, does that file still load?
Yeah, it's very odd. It just seems like it was kind of just blown off. Maybe the triager even knew that was the case and just didn't want to, get into a debate with the researcher, which I don't know how I really feel about that. Like, if that's the case, I don't know.
It should have been closed as like
not an issue, or won't.
Yeah,
fix
like
or
there are
whatever.
other options besides just resolved. Partially because marking as resolved also ends up increasing their signal ratio, like the researcher's signal ratio, so other places kind of know how often they submit good reports versus bad reports.
Yeah, kind of muddying the stats there.
Yeah, so I feel like it's probably, they just saw it as an easy way. Oh, well, it's been fixed. They didn't even get around to triaging it, so whatever.
Yeah. There is one thing in the steps to reproduce that I found really odd, and I couldn't understand what they were trying to say, which I thought was pretty funny, so I'll point it out. The last step to reproduce: open your network browser. This JavaScript source has high files, can lead to DOS. I don't know what they mean by high files can lead to DOS. Do they mean just loading large JavaScript files? I don't know.
Yeah, neither do I. I feel like that was probably a language issue. So
yeah,
I just kind of overlooked it. I figured the DOS could be, the API key, you overuse the token, cost the company a lot of money, denial of service in that sense if you hit any sort of quota
that could be a
limits.
charitable take on it, yeah.
But I wasn't sure what they meant by high files either.
Yeah, the way I read it was like using, large JavaScript files can DOS the client or something, which is like, okay. Seems kind of weird to mention in there, but yeah, the one using the API key to DOS the API, that's a more charitable view, and it does kind of make sense, but like you were saying earlier, I just don't really see like a, neat solution to that, so.
Yeah, for the API key, like it isn't the ideal case. For sure, like Balika mentioned in chat, they're like poorly designed API. Like there just aren't a lot of options to do that client side stuff. Yeah. Like if you've got a good solution, I'd be interested to hear it. But as far as I'm aware, there just isn't a good option unless you just want to remove it from the client side, which is fair. In a lot of cases, it's probably better to do that. Because I've definitely seen a lot of applications that'll misuse the API keys. So it's like, I could understand somebody seeing that and think like, oh yeah, it's the full API key. But if you're aware that these client-side ones exist, it's worth figuring out, what the keys actually do when you're making the report, rather than just assuming it's an API key, therefore it shouldn't be shared.
Yeah. So our next report is pretty interesting. It's not something that I've really seen before, but it's basically using unvalidated OAuth emails to perform account takeovers on third-party sites. So basically, if you've ever seen like a site that says you can create an account or you can sign in through Facebook or you can sign in through Twitter or whatever, some sites allow you to sign in through GitHub or GitLab, sorry. And that's basically using OAuth or, authentication. So, you use OAuth, you get a token, and then that token is used to, associate with an account. So what happens here is kind of weird. It basically seems like you can use unauthenticated, like unverified GitLab accounts to create accounts on other websites. So, you can use the sign in with GitLab, and normally if you don't verify the email is, associated with the GitLab account, it gives you a prompt to validate the email. But they basically found by just replaying the CSRF token and the cookies and the state information, they could kind of
I
just
wouldn't
like
call it
replay
replaying.
Okay, that's how I
Because
kind of took it, but maybe
yeah,
I'm
so I mean,
a little off there.
I am going to assume you're just not familiar with kind of the normal OAuth flow. But usually kind of how it goes is, or at this stage, the authorized endpoint is where you should be redirected next. Like, they basically just created what the next step would be according to the proper steps, rather than actually being redirected to it automatically.
Okay.
So like the actual thing would have been to send them to this authorized endpoint. It just, GitLab was like, hey, your email is invalid. You shouldn't be going there. So let's give you this other prompt. But if you go and make that request manually, hit the authorized endpoint, passing in your CSRF token, passing in your cookies, basically, making the request as if it were legitimate, as if you were actually forwarded to it. It didn't actually check that anymore. It just assumed it was done at the earlier step. But yeah, this is the next phase in the OAuth steps, basically. You'll make this request, and it includes where is it? Like this redirect URI. You make this authorized request, it's going to redirect you back to the actual website with a token that other website's going to use now, and that's where it's going to be able to get your email and stuff from. So yeah, in this case, you skip that validation, and it still sends kind of your or it still gives the other website access to see, hey, this user's GitLab account, here's their email. So if that user, if you did that to somebody who wasn't a user already on GitLab, but was a user on this other website that you were trying to log in with, it would log you in. In theory, it could log you in as that other user on the other website because the emails match. It thinks, hey, you've got this email, you must be the same user. And like you said, I haven't really seen this before. It's an interesting attack. Like, I'm obviously familiar with getting onto internal websites with, mailing lists is one of those common things. If you can get access to a mailing list, you can have kind of an internal address and get access that way. This is another kind of way of getting internal access. I mean, there's a ton of things you can do with this beyond that. That was just kind of the first thing I thought of. But yeah, it's not something I've really seen before. Yeah.
This is one of those attacks where it's not like something that's just kind of copy and pasted and applied across, multiple things. It's a very specific issue to how GitLab handles it, right? So, yeah, definitely not something you see every day.
I can imagine other places though sending, like, especially if they don't validate, like if you have another way to register without adding an email and then you add an email after the fact, like I could see other OAuth systems being vulnerable in similar, maybe not this exact way of being able to skip that step, but this idea of using the OAuth to hijack an email on another system. like that idea, I think, is the more general takeaway from it. Which shouldn't happen, but can happen, and I can imagine there's more than just GitLab vulnerable to that.
So I like that aspect of using it to get into internal company pages. I remember we actually did have a discussion on the podcast before about a different attack that did that, but I couldn't find the episode that we talked about it, unfortunately.
Yeah, I
But
believe
yeah,
that one used the email technique that I was talking about. Wasn't that would have been our episode, the black white hat hacker? It was that
oh
guy
right,
that did it, yeah.
yeah, because he
Whatever
traversed
episode
the
that
network.
was.
Yeah, so you can find that by the title. But yeah, getting into some of the meta details, it got a payout of $3,000, not bad at all. It was resolved within a month. There was a bit of a delay between it being resolved and being published. It was resolved a few months ago, but that's usually the case with a lot of reports that are disclosed. I will just say I love his name. His name is Cash Money, Cache. Cash. Like that was kind of a clever name. I just noticed it when I was like looking over the report just now. So pretty funny name. So Grindr. So dating apps, especially I don't know how they're doing right now with the whole pandemic, but Grindr is a popular dating app used by the LGBTQ community, which is important because it's an app that you want to keep secure, and you don't want people necessarily knowing you're on there, especially when you have some countries that have very negative views towards the kinds of people that would be using the app. And there was a security researcher who found an issue that allowed account takeovers, and they attempted to report it to Grindr, but he said the vendor keeps ignoring me. So the issue is a very trivial issue. It's in the password reset mechanism. Basically, they send a password reset request, but the token is embedded in the response. So you can just paste that token into into a query in the URL and reset the password. It's really odd. Um, so the Grindr support rep stated that they escalated it to the developers and immediately flagged the ticket as resolved. Um, and then their contact followed up the next day and asked for a status update and got nothing. Um, so yeah, kind of an interesting story. It's more interesting on the I guess political or discussion side of it than it is on the technical side of it. Um, so this person, they reached out and tried to get it fixed. The story does have a bit of a happy ending. Obviously, the bug was fixed. Grindr is also now partnering with a security firm to help improve the security stance. And they also mentioned that they're going to be starting a bug bounty program. I don't think they mentioned a target date or anything when they'd be launching that, but
Yeah, and the other thing is they just gotta say a security firm. I have a feeling this might be HackerOne just because of how popular they are. Again, one of those pure speculation things. I will also mention, since if you're listening, you won't see this, but this is Troy Hunt that the original researcher kind of reported to and said I was ignored. And Troy Hunt actually had issues getting hold of Grindr too. He ended up putting out a tweet asking if knew anybody in security at Grindr, and of course got some responses there. But apparently somebody responded to him saying, "Well, hey, Grindr has open DMs. Like you could just DM them. You don't need to make it all public." Well, it turns out he had actually done that, and Grindr had ignored him already.
well, I
So,
wasn't totally sure if he did that or if he just said that the other person already did that and it didn't
well,
work. But
no, he mentions down towards the bottom, he got a message from a friend there. This was Troy Hunt after he sent the anyone got security at Grindr they can connect them to.
oh yeah, okay.
Mentions a friend actually DM'd me saying, not sure that Grindr tweet was necessary given their DMs are open, and they reached out to you fairly soon after. But it does show here the tweet there being hello, I'd like to know if you have responsible, like shows this there where to contact, trade the ticket. Basically nothing comes out of this.
Yeah, and he mentioned, if it wasn't for him making that public tweet and it getting attention and people thinking, oh, what's going on? He's tagging Grindr, that must mean there's a security issue there. He mentions there that he thinks if he didn't do that public tweet, this probably wouldn't have been addressed.
That's
Um,
my thought too. Is yeah, sure, they responded pretty quickly. Um, yeah, and that's definitely a positive thing. Like he got in contact and patched within they took it down within an hour and a half, and then shortly after, which isn't specified exactly how long, they had it back up with a fix. So let's say like 2-3 hours it was fixed really quick. Like, that's a great response time, like really good turnaround time, something you could be happy with, but probably only happened because of the Twitter attention that was there, because they've already shown their willingness to ignore the reports or not triage them appropriately, sending it resolved when it wasn't resolved. The other thing is, Grindr did put out the message there saying that they believe they addressed this issue before it was exploited by any malicious parties. Seems like a hard thing for them to verify whether or not.
Yeah, I was thinking that too.
I mean, so of course they only say we believe. Like, it's a wiggle word. Their belief is that it wasn't used. I do want to point out, it's hard to say. And the other thing, you're kind of starting to touch on this, I think, the political aspects of like Grindr. If you're on Grindr, sure, in some countries, like we're both in Canada, LGBT rights are reasonably established.
A lot better here than some other countries.
It's not a huge risk. Whereas they do actually mention, Troy Hunt mentions here about Egyptian police using Grindr to find and arrest users. So like there's kind of the risk on that level. Obviously, some people just don't want to be outed. So if you're able to use this to get access to a lot of information. I was actually surprised they have HIV status as one of the piece of information in the account, which, okay, I kind of get that also, but
obviously very sensitive information.
Yeah, like that's not something you want just anybody able to get access to.
Yeah. This story kind of reminds me of that one we covered. I can't remember if it was last episode or the one before that, but it was the women's only like meeting app or whatever it was.
Yeah, the social media thing.
Yeah, the social media app, that's what it was. Kind of similar in like the kinds of personal details it exposes, although this one I think is worse. But it's interesting with like how hard it was to get this issue through, but then also how quickly it was fixed, and the fact that it seems like they are trying to fix their security stance. It makes me think that it's mainly like just a communication breakdown at the lower levels, I guess. The levels on like the social media accounts, because the people operating the social media accounts, they probably don't really care or know much about like security and stuff, because we've seen posts in the past where people try to report through Twitter DMs and it just doesn't work out. The person operating the Twitter account just doesn't really understand or doesn't know where to direct them. I think that might have been the case here, just because there's such a stark contrast between how it was remediated and how it got there. So yeah, I'm gonna take a bit of a charitable take there and say it was a communications breakdown. So hopefully that can be fixed. But this is kind of another,
because apparently they were able to create the ticket that was immediately closed, and mentioned that it was being escalated. That definitely raises some more concerns than just the communication breakdown. Could be a misunderstanding. I could definitely see this being the type of issue that a developer just, well, of course they need the token, and kind of ignoring just misunderstanding how they're getting the token. You're like, well, they need the token, what's wrong with this? Like, it seems fine to me. Resolved. Like, I could see there being kind of like a dev misunderstanding too.
Yeah. Yep, I can see that.
Like, I mean, most people are maliciously being like, we don't want to fix these issues. Like, that's usually not the case. Although it definitely has been the case. I guess, like you were just talking about that other social media platform. That one, the owner said that it was all lies and stuff like that. So,
and there was even threats of lawsuits involved.
Yeah. So, generally speaking, though, it's not the case that people are actually trying to be malicious about it. So, yeah, I think the communication breakdown is the most likely explanation. Maybe not just at the front end, like at the low level, but it could have been with a developer just misunderstanding, making a mistake.
that's just another example, though, of why, companies really need to start making sure they have, secure channels of, or like
A
clear
vulnerability
channels of
disclosure
communication.
program.
Exactly, yeah. Clear channels of communication for those types of issues. Twitter DMs and stuff are just not a good avenue, but unfortunately, in many cases, it's the only avenue. So, that's something that just another trophy in that case to point to of why you should start a VRP or something.
Yeah, and I'll
So,
give a quick shout out to security.txt as a file that you can just put up.
yeah, I remember
Oh,
seeing them trying to get that more used, like, robots.txt kind of
yeah,
standardized.
it's done in a similar way as robots.txt, but for security. And actually, I want to say this is also suggested by like Live Overflow.
He's definitely supporting it. I've seen him like
I
retweet and
think it
stuff
was
about
his
it.
idea, actually.
Oh, I don't. Okay, I
I
know. I
think
know he supports it, but I didn't know it was his idea,
I think
or
it
if it
is.
is.
So I'll call that out if I'm wrong. Well, we're still giving him a call out, our small little thing here. Not like it matters, but no, I mean it's a good idea regardless. Having that, it's a constant place you can look rather than, oh, are they on HackerOne? Nope. Are they on BugCrowd? Nope. Are they on whatever other platform, or is like trying to hunt it down. Having that
Doing
common
open source
place
intelligence on the
is,
company
yeah, having it in a clear place, I think is valuable and a good idea.
for sure.
And of course, having a vulnerability disclosure program. You don't need to pay a bounty, but having a route for disclosure.
So we love ZDI as always, and we have two posts this week. The first one is covering IBM WebSphere, which is a middleware application server written in Java. So this article goes into a few issues. I think there's two CVEs. One is an authentication bypass. It's not super exciting. It's basically just a logic bug in the authentication handler. If the token that is passed can't be validated, it returns a subject of unauthenticated, but the code checks for a null, not for the unauthenticated string. So basically
Which,
just an incorrect return check.
yeah, it's an interesting case though, because I mean, kind of thinking about from the developer's perspective, what's going on here is the developer, they probably have this authenticate token, which is the particular method that's being called authenticate token. It's passed in the token to be authenticated, and it's supposed to return a subject. So what they do is they return, oh, if this token was invalid, let's just return the subject as unauthenticated, which I'm going to say is probably a bad choice. Like if you're designing a system, you shouldn't have like that sort of string that needs to be checked for. Like the error should be more obvious. The error value should be more obvious. It seems like whoever was calling this function was just expecting it to return a null if it couldn't pull out a string, or if it couldn't pull out a subject, rather than the authenticating. I can understand what a developer was thinking, that, oh, it's just so much easier if it's all the same. You just have to remember to check for unauthenticated. Then I don't have to worry about, the null pointer dereference or any sort of exception coming out from that. Like, I get where the dev came from in adding that. It's definitely one of those common error paths, though, or sorry, common vulnerable paths. When you kind of see this mixed use of return value types.
Yeah, it's an example of how lack of clear documentation can kind of come back to bite you. This is why,
Documentation,
like,
but also just kind of this like this is kind of it's very similar to the idea of a magic number. It's just this number, it's just this string that happens to be in the code that you have to look for. It has, like, sure, it has like a meaning as you read it, so that's where it does differ, but it's just this kind of random value. I mean, unauthenticated could have also been failed or failure or so many other things, whereas returning null, at least in this case, is kind of, you get what's going on when you get that value, and if you get a null pointer, it makes sense, rather than kind of still being a valid value, just a special value.
This type of issue is why when I'm writing code, that I'm expecting other people to read and use, I always like putting in a comment for the function what it returns on success and what it returns on failure. So I'll put like returns the subject on success or null on failure or unauthenticated on failure. It just makes it so much easier for anybody who wants to invoke that function. All they have to do is quickly check the definition. They see the comment there, and then it's very clear what to expect. And it seems a lot of code they just don't really care to do that, and you have to read into the function, and sometimes that's not always easy. If it's like a nested function or whatever, you have to go through all the levels to figure out what it's returning. A comment can easily clear up that kind of confusion, and probably would have helped in this
Can
case.
clear it up. It can also create problems where, oh, you added an extra error value in some other function that it calls, and you don't update the function. Comment the higher level comment to actually know about that, basically. I've honestly been adopting more of the Go style in other languages.
I love Go. Yeah.
I mean, I definitely like the error pattern there. You're returning your errors, you have to deal with them right there where they happen versus exception handling, but
Or explicitly say that you're going to ignore it by using an underscore,
yeah.
which is kind of like with Rust with the unsafe keyword. It's kind of red flag that I know what I'm doing. I'm going to choose to ignore it here. Or if there's an issue, this is probably the first place to look. So yeah, the Go style error handling is definitely really nice, and should be learned from.
Yeah,
The
I
other,
mean, but in this case, it's one of those things like when you return kind of a valid value that has a special meaning, it's definitely something to look into because there's a lot of vulnerabilities stem from that.
yeah. So once you have that authentication bypass, a deserialization path is reached, and that's where the crux of the CVE comes in. They have the unmarshal function, which has a deserialization attack. Now they do state it was tricky to exploit this because the IBM Java SDK has mitigations against deserialization. There was a gadget that they were able to use, which they detail in another blog post, but you know we're not really going to go into that here. Deserialization gadgets are kind of you just find one that works and go with it, right?
Yeah,
Um,
I mean, it's easier said than done, of course. Like, this isn't like Ruby where you have a universal gadget. With Java, like you have to dig into the application's code to do it. But it is always just that you're looking into the code to find, ideally, like your arbitrary function call, and then you can chain deserializing a couple of them to actually do more. Is one example. They dig into it. I just feel like we've kind of covered the issue a good number of times that I don't think it's worth us kind of digging into how this one in particular worked. Although it is worth, like, if you're interested, you can either check out the other post that's linked in this one, or what I would recommend is Portswigger's Web Security Academy. They have exploiting insecure deserialization vulnerabilities, ton of information on how to do it. I just recommend going there if you actually want to learn more about it and finding them, and then taking a look at the WebSphere case. And that link will be down in the description.
So the other issue is a directory traversal in the upload file mechanism, which is reached through the broadcast message subsystem. So basically, through broadcast message, you can send different types of commands or messages, and one of them is the ability to upload file to all nodes. And they don't do any restrictions on this upload. You can just upload anywhere on the target. So the fixes for these issues were what I like to call Sony fixes, because the deserialization fix was made back in July, and basically all they did there was make sure that it's authenticated, which they just fixed the authentication bypass. So I guess the deserialization issue is still there because they don't mention explicitly that it's been fixed.
Which, in fairness, is what they've done with all of their deserialization things. It's what they mentioned, that WebSphere has the deserialization issues before, and what they've done as addressing it is just ensure that authentication is required before reaching any of that deserialization code. Basically, like, if you need to be authenticated on WebSphere, you're able to upload applications, you're able to add applications that are going to be run on the server. So getting code execution, like, you're not escalating at all, or you're not really escalating much. You could definitely make the argument that there is, but the type of server that it is, if you're able to log in, you're already able to execute code.
The directory traversal fix was just removing the file upload functionality altogether. I guess they just deemed it wasn't necessary / worth the risk. So, I mean, it's definitely valid. The issues aren't hittable anymore, but they're not like fixed in the way that the issues were directly addressed. They were just kind of, they were either just blocked off by an authentication wall, or the code was just removed that contained the bug. So,
I mean,
fair ways of fixing it.
It's a good patch. If you just remove it, it's not vulnerable anymore.
Yeah, and you're reducing attack surface. So, it's definitely not bad. A bad way of fixing it. It just feels cheap to me. But, that's probably just my personal opinion.
Yeah, it's maybe not an elegant solution, but it's one that works.
Yeah. So, our second ZDI post dives into routers. So this one has 2 authentication bypasses. One of them is suspected to be an intentional backdoor. That'll be kind of interesting when we get to that. Both of them are in the Home Network Administration Protocol, which is a SOAP-based protocol. So the first issue is basically an incorrect use of stir-n-comp. So they use stir-n-comp to compare the server calculated password with the login password sent by the client. The problem is they don't check for null passwords. So stir-n-comp, for those who don't work with C or anything like that, pretty basic function. It just compares a string up to a maximum of n characters. If it's equivalent, it returns 0. If it's lesser than, in terms of like ASCII characters, it'll return, a negative value or a positive value in a greater than case. So because they don't check for null passwords, you're basically comparing a string length of 0, which when passed to stir-n-len compares 0 characters, which returns 0. So, passing a null password basically gets interpreted as an equality.
So, I mean, you're saying password, but it is kind of worth pointing out that the way the authentication system works, if you just entered like an empty password on like a prompt, you wouldn't end up hitting this vulnerability. It would still kind of be hidden from you because it's not there's like a basic authentication, HMAC based authentication. So we're talking about the HMAC one. Basically, it's kind of like your standard challenge response type of login, where you send the request there, I'm going to log in, you get a challenge back from the server along with a public key, and then you combine your public key and your password to create this new private key. And then that private key, you combine that, or you use that and the challenge to generate some new value, and that's what's sent as the login password. So even if you entered like a blank password on like a prompt or on like the official UI, you wouldn't hit this. But if you had a malicious client or like, a modified client that knew to send a blank login password, then you could hit this issue. So that's why it wouldn't have been discovered so easily. It's just because it required taking advantage of how that authentication worked by creating that new challenge value. I might as well continue on. The second vulnerability, the potential backdoor or sort of admin access, is really weird. But if when you do the login request, if instead of just sending the login password, you also send this private login field, you could include kind of a username. So rather than so the server is able to create, when it gives you the challenge code, it knows what your password is. It's able to kind of recreate what the private key should be. I didn't mention that explicitly before, but I will now. So it knows what the private key, what the login password should be for that challenge. And then with the user, it's just going to compare that, hey, the user actually used the right password. They generated the same login password. So what's interesting here is using this private login field, you specify the username. And then the server does kind of a different way of generating that login password. Instead of combining the public key with the password, it combines the public key with the username. And that's what it uses the username instead of a password as a password. And of course, the username is something you can figure out. So as long as you know the username, you can log in as long as you send it as this private login value. So it definitely sounds like a backdoor. Sounds like one of those things that unless you know about it, you're probably not just going to accidentally happen upon it. And it doesn't have a really obvious use as to why they would do it this way.
Yeah, that's what I was thinking. Was it's pretty suspect because it seems unlikely that this was just a development backdoor. It seems a little bit too sneaky for that in a way.
Well,
Um,
that and it doesn't make sense if a developer were going to enter their kind of backdoor, maybe for their technician backdoor or something, you could do that securely. You wouldn't go through this whole weird thing. You could have a public key, or sorry, a private key that the technicians have access, they can sign something with, or there's a lot of ways you could implement that. Changing it over to using the username is just, you're just kind of left saying what? It just makes no sense here.
yeah, it's very weird. There's some spicy elements to this article. I think the last sentence is throwing some shots, I guess. And the quote is, "Perhaps it is time to consider consumer grade routers disposable items." uh, I'm guessing just touching on the backdoor issue and the fact that routers just have so many issues. They're kind of just crapware when it comes to security. Um, I don't know how you feel about that, Z. Would you agree with that quote?
Uh, I can agree with it. I mean, we kind of need them. I
Yeah.
think the manufacturers need to spend more time on security and all of that.
So basically, the point they hit on there is that the hardware has a tendency to last longer than the support lifecycle, right? So, if you have a router that has a vulnerability 4 or 5 years down the line, and that's out of the support lifecycle, you're screwed unless you manually patch it yourself or flash a custom, firmware on it or something. I think that's where they're kind of hitting on where, you know, it should be disposable and you should get a new one every, however long the support period lasts, which I don't really know how feasible that actually is. Most people probably don't really want to go messing around with the router and setups,
Well, a
especially if
lot
you
of people
have.
get it from the ISP too.
Yeah, I mean, most people get it from the ISP, but the other thing that's worth considering too is if you have custom firewall rules or, um, any port forwarding or anything set up on the router, it is a real pain to port that over to a new router. So it's not something that everyone can just switch over easily. So that's kind of the problem I think with that, mantra. So
Although
I
if you're
agree with it,
setting it
but
up, if you're the one who's kind of doing that setup, though, you probably can figure out how to back it up and restore it elsewhere.
yeah, that's fair. But I mean, it sounds like a nice quote. It just seems like one of those ones where, yeah, sounds nice, but it doesn't seem like it would easily translate into, real
I
world.
think the bigger thing would be that they should be maintaining them longer because they last longer.
Do you think they should be legally enforced for a minimum support period
Oh, that's
from IS for to
having
ISPs?
regulations at that level. I, I don't. My initial thought is going to be to say no. I don't think they should be regulated at that level. I don't think the government needs to step in to say, "Hey, you router manufacturers, you need to be updating them for however many years." I think they should have that. Sorry, not the government. I think the manufacturers should be doing that. I don't think the government necessarily should be the one stepping in to try and enforce that. I think there are
See,
other problems the government can deal with.
the only reason I say that, and I'm not going to try to turn this into a rant about ISPs, but ISPs and like router manufacturers, they don't seem like they care. They don't seem like they they don't want to do more than the bare minimum, it seems a lot of the time, which is why I feel like if you wanted them to offer longer support periods, you would have to force them to. That's kind of where I was going with that question. Um, yeah, it does open up some, I guess slippery slope is the coin term for that. When you get like government regulation and stuff stepping in. But I feel like where routers are so important and everyone has to have one, and the internet is where most people do a lot of things, especially now. With regards to like their personal, financing, like everything, almost everything people do now is on computers and through the internet. I feel like it might be worth considering that routers should be getting protected better, and if the manufacturers won't do it, I feel like somebody should be making them do it.
Perhaps, but something like this isn't, internet exposed. It's going to be attacked by somebody on the local network, which is a possibility. I mean, malware can definitely use that. Your random IoT device gets compromised and they pivot over to the router. It's another fair thing, although some protocols also won't be exposed unless you're wired in versus wireless. I don't think that's the case here, but just speaking generally. So,
Yeah.
I mean, in this case, I don't know. I mean, there's a risk there. I agree with you. That doesn't seem like a lot of them are taking security seriously, at least the consumer grade level. But at the same time, I don't think it's really the government that's going to come in there, and I don't think the risk is that insanely high. Just because of the fact that it's generally, internal access, it's generally not exposing admin interfaces to somebody who isn't already on the network, which limits what somebody can actually do with these vulnerabilities. It's still not good. I'm not trying to defend it as like, yeah, that makes it totally fine to be insecure, because it doesn't. There are ways that it could be compromised. I just think that is definitely a mitigating factor that needs to be considered.
Okay. Something I wanted to pull out of chat. Blog author on Twitter from JDogHS. The blog author put on Twitter a random fact. I was once tested on the code pattern in the first bug in the interview, in an interview, which I'm not totally surprised on that. I haven't done a ton of security interviews, but I've definitely the one or two that I've done. These types of issues are kind of you know, they're definitely not uncommon from what I can tell. This seems like kind of one of those entry level logic issues that shouldn't have isn't really too excusable because it seems kind of obvious, but you know maybe that's just my bias talking. So it could be just anecdotal.
No, I mean, it's misuse of, like, it's almost one of those gotchas. Like, once you know about it, you know about it. But I could understand a developer who doesn't know about the zero link string compare is always going to be true. Like, I mean, it seems reasonable. Like, you could understand that. But if somebody were to approach it and their initial thought is, well, if there's no string, it must be false. Like, comparing any string with no string must, not actually compare. Like, it's a clear error case in their mind. I can understand where the devs come from with that. But once you know, you're probably not going to forget that either. Well, you might. I guess it depends on the developer. As a security person, once you know that, you know that.
Yeah, that's a fair way of putting it. So Punkbuster, this is a name I had not heard in a long time. So Punkbuster is an anti-cheat. It's a very old one. It used to be used in Battlefield and Call of Duty and probably a mixture of other games, but those were like the two, key games that had it. It was all right for its time in the 2000s, but as time went on, it kind of, it fell behind. It kind of turned into a bit of a joke. But here, this author Daniel, he pwns Punkbuster's server to get remote code execution via directory traversal. So it's not hitting through the client, but it's hitting the server, which is obviously a lot more impactful.
Also, an
So
interesting case that he was able to test the server code.
yeah,
They do mention that they're not going to get into the details about how they got that, but just worth pointing out. I mean, it's not something that I think is freely available. I mean, perhaps there is like pirated version or something out there. I can't imagine It's one of those heavily pirated things, though. So, and as
Yeah.
far as I'm aware, it's not available.
I think you have to like contact them and buy it and stuff. Yeah, it's not like easily accessible from what I could tell. So it focuses this post specifically. It focuses on the screenshot subsystem provided by Punkbuster, which can allow server operators to request screenshots from game clients, either intermittently or just on a schedule, like on a timer. So the client can specify the name of the screenshot, and you can kind of see where this is going. You can just pass a name that traverses a directory and even has a different extension, and the server will just accept it. So pretty trivial issue, but what I thought was cool here was even though Punkbuster isn't really used anymore, Even Balance, which is the company behind Punkbuster, quickly responded and issued a patch that would automatically deploy to all servers that are currently running it. Um, which is kind of cool. It shows that Punkbuster was, even though it fell behind in some regards, you know, it shows that it was a little bit ahead of the game when it came to updates. The fact that it's automatically deployed, I think, is a really good, I guess, defense and depth measure. I guess I don't know if that would be the best term for it, but um, yeah, it just shows that how useful auto updates can be when it comes to security. They also note that the client side is obfuscated, so implementing this exploit wouldn't be trivial, even though the bug itself is trivial, which kind of makes sense when you're talking about anti-cheats. They're going to have anti-reversing and anti-tampering measures. That's what they're designed. That's literally their threat model is stuff like that. So, um, but yeah, just kind of a cool post. Another one hitting one of those older systems that used to be super popular. Might not be anymore, but still an impactful attack.
Yeah, and I guess I do want to jump back on the actual issue,
Okay.
just because the client and server aspect of this kind of gets a little bit, I don't want to say twisted around, but you have the server admins who can send messages to the server that will then send other messages to clients who are playing the game. So like the admin who sends the get screenshot command with like the delay, things like that, that there's still a client, but also the client is the gamer. So the gamer is able to just send the body and whatever they want in the file. Basically, as Spectre was saying, the traversal, they're able to send that even if the admin hasn't sent any other messages, like hasn't actually requested it. They're still able to just send and upload a file, and the file itself is uploaded in a directory traversal to the server. So you're able to compromise files on the server through the client. Because a lot of directory traversals also involve downloading, whereas this one, actually, I'm not sure if the admin would also download the directory traversal or how that happened. I don't know if that was actually called out here. Do you recall, Spectre? Is that called out and I'm just forgetting it?
I don't remember it being called out.
Yeah, okay. I didn't think
Yeah, I
it
don't think
was,
they
but
were
I thought
too big
maybe
on
I was
that.
just forgetting.
Yeah, but yeah, still, cool issue. Thanks for bringing that up. By the way, that's a good point that I kind of forgot to mention. So our last exploit topic before we get into some shoutouts is a race condition vulnerability in the handling of PIDs by apport. So apport, it's basically an Ubuntu crash reporting service, um, and this is a time of check, time of use issue. So when it comes to being able to debug using a user mode helper, which happens when the first byte of the special Linux file proc sys kernel core pattern is set to a pipeline, that basically makes it so that the core dump, when a process crashes, is piped to the standard input of that helper process instead of to the file system. But the PID of the crashed process, isn't locked by apport, and another process could be spawned that could occupy the previous PID of the crashed process because PIDs are reused, right?
Yeah, so it's the
Um,
kernel that's not keeping the crashing program opening.
yeah,
Apport, it does a little bit of work, but it's the kernel that isn't doing that. It just, in a lot of cases, it happens that because the kernel is writing so much data, by the time Apport opens, it will, like the crashing program will still be open. But it's not Apport that's actually doing that. And I do want to mention it's not really clear in this article, but this is not something that's enabled by default. This is something, or like they don't have this enabled on stable Ubuntu releases. It's only on the development releases that has this by default, which definitely limits how this is going to be actually hit.
The
Or
impact
who's
is
going
a
to be
lot
vulnerable.
lower.
Yeah.
Yeah. So, yeah, basically that issue of the PID being able to be recycled is the core of the issue. Now, there are previous exploits that were actually based on this. There was like a 2015 CVE, a 2019 CVE, a 2020 CVE. So, previous vulnerabilities would abuse that to put a new PID in there of a privileged process that things like stat, CWD, and maps could operate on. So they attempted to prevent this issue by um, opening the PID directory first with open@, where they just store the PID and concatenated it into a path before. That way the directory is replaced, and trying to write to it will fail once that directory is replaced. But this issue specifically touches on the fact that it's possible that the process PID could already point to another process before or when apport is launched, and even has a chance to, perform that check. So it's still kind of the same attack, but it's a slightly shifted window and a smaller, technically a smaller window, but they do actually expand that.
And so the 2019 attack, what it would do is it was used basically, you could use it to like break ASLR by having a high privilege process crash, but then having its core dump be lower privilege by changing out the PID. And we keep saying PID recycling. The whole idea there is there's a limited number of PIDs that a Linux system has. I want to say like 32,000 or 65,000 or whatever.
Yeah, I think it's near one of the boundaries of integers.
Yeah, I'm not sure if it's signed or unsigned. Either way, you've only got so many PIDs, so when a program crashes, that means another program can start using that same PID. So occasionally, if you can either allocate them really quickly or something like that, you can get another program to execute with that same PID. So you're able to reuse that PID, and then a program that's trusting things based on the PID is able to, will trust your new program instead. So that's kind of what we mean by the PID recycling. I think we kind of glossed over that a bit. We've talked about it before. There was a... Do you remember what episode when we talked about like the Linux kernel protections over this?
I
I
want to say it was like late last year, but I'm not like 100%
yeah, I
confident
forgot
on that.
to look that up, but we've talked about this a little bit more in depth when talking about new syscall being added. I think it was like Linux 5.3.
Yeah, it was a keys cook post. I remember that
one
much.
of
It was
them.
one of those Linux security in V5 point whatever, which we covered one of those last week, but it obviously wasn't that one because
No, it was an older one. It was 5.3. I found which one it was. I just forgot to look at the date for it. Either way,
no.
jumping back to it if you want to carry on. Sorry.
Yeah, so it's just it is a slightly smaller and shifted window, like I was saying, but they do go through a technique they use to make the timing more likely to succeed by using an environment variable. So there's an environment variable called dbus session bus address, which when it's specified, um, apport tries to send a request to the TCP server specified in the variable. So it takes the address in the variable and tries to send a request there. And that request is not sent as like a non-blocking request. It blocks. So if you just specify a TCP server and run a server there, but you never process any requests or anything, you could just block it and allow expand that window so that it's a lot easier to hit. Now there is still some timing issues, and they kind of go into that a little bit more in the article. Basically, how they escalated was they chose a specific process to slot into that old PID, which was log rotate. So log rotate runs as root. It can chdir into a controlled path via configuration. And those are like two keystone things that made it a very viable process for them to use.
Yeah, I
So
really like this attack method. And that is a key difference here between the 2019 one, is that 2019 they went from having a high privilege process crash and reading its core dump, so kind of high privilege to low privilege. In this case, they're going the opposite direction. They're crashing a program that they control, just sending a signal over to it, crashing the program they control, and then having it replaced with the higher privileged one that's going to write out the actual core dump. Basically, by using log rotate, as mentioned, it's running as root, so they go from the low privilege original to high privilege, runs as root, runs log rotate, and log rotate files in general are very forgiving of random data. So in this case, core dump gets written out as a log rotate file into etc logrotate.d. It skips all the invalid characters, so next time the log rotate runs on that directory, it's going to read that core dump and think it's actually a script for log rotate, and there's any number of places you could put scripts in there: pre, post rotate, pre, remove. I think they use the first action one. But yeah.
Yeah, so you can execute arbitrary commands as root.
Yeah.
That's basically the crux of it there. So the fix they deployed is it? I looked at the diff file that they linked. It seems they basically just checked the process start time on the PID to see if it was created after the crash time, which kind of makes sense. I do have a few questions here with this though. I do wonder why they don't just lock the PID down or keep a list of dying PIDs in the kernel that can't be reused until apport is finished with them. Because I feel like after so many issues have popped up due to this like root issue, that it would just be addressed at the kernel level. And
it's apport that has this issue. That it's just assuming that the kernel's even keeping it open for it. The kernel is just sending its crash dump over. I don't think the kernel has any responsibility to like keep the crashing PID open for some reason until
I guess that's actually a fair point.
Where it's being piped to is done. The program crashed. It's just here's all the information about here's what PID was and stuff for logging purposes. I don't think it needs to be responsible for that.
Yeah, and now that I think about it, it is kind of unreasonable to put that responsibility on the kernel. I mean, I guess my problem here is it seems like this fix is a little bit hacky. I don't know if you can easily mess with process start times. I've never really tried it from like an unprivileged context, but if you can, then this fix seems like it could be bypassed.
In a sense, so like the whole the way apport is working is a little bit hacky to begin with. And to be fair, like it's meant for the development builds. This isn't active unstable, which is what most people are going to be running.
Yeah, I mean, that is a little bit interesting because that fact is not reflected in the CVE from what I can tell. I'm just looking at the CVE and it doesn't seem like... Let me just double check. Yeah, they don't explicitly mention that it's not in the stable builds or anything. And, in the CVSS, they don't mention that... Well, CVSS is a little bit hard to specify that, but, it says privileged required low. Like, it's not as accessible as the CVE makes it seem like it is. So what you pointed out there is pretty important. I do have kind of a, I guess, hot take question. Do you think we still need recyclable PIDs? Because, I feel like at one time we definitely did, right? When we were running on like 32-bit systems, integers could only be 32 bits wide. Now that we have 64-bit systems, do you think that we still is anybody going to be using the unsigned max of the 64-bit int? Like, is there ever going to be that many processes launched to the point where we actually need
I'm sure there
PIDs?
will be, given long run times. I'm sure somebody somewhere can fork bomb hard enough to do it.
Yeah, I guess it's kind of
and have the specs to survive it.
Yeah, I mean, I guess it's kind of an edge case that you have to account for. Part of the reason I was thinking about that was Something that you could kind of compare this to in a way is a reference count overflow. So like if you have like a kernel does this a lot. If you have like an object that can be used in multiple areas, it's not like easy to track. You'll use reference counting. So every time something accesses it, it increases the reference count. If it once it's done, it decreases it, and if that reference count hits 0, then it frees the object and cleans it up and whatnot. Now, one issue that has popped up in the past is what if you increase the reference count but forget to decrease it because of some error path or something? And when that happens, you can leak the reference count and overflow it. And when that happens, you could overflow it back to 0, and then it gets freed, and you get a use after free scenario. Now, one of the ways that at least in like the Linux kernel that they kind of combated that is most reference counts now, where they used to be like uint16s or shorts before, now they're 64-bit integers. And so even if you find that type of bug, good luck exploiting it, because overflowing a 64-bit integer is going to take forever. So in theory, yeah, it's an exploit, you can hit it, but in reality, it's not reasonable, because it would take like days or weeks to overflow that, and that's just not a reasonable runtime for an exploit. So that's where I was kind of thinking, transferring that over to PIDs, if you just make it so that the PID doesn't need to, wrap around and reuse PIDs, you could eliminate this type of issue entirely. That being said, it might not be worth it either. I don't know how many other, types of programs this issue would affect.
No, and I mean, they are taking steps against the PID recycling with the PID FD stuff. With the
which
addition
is
of that
actually
syscall,
a very good point, which I hadn't even thought of.
Which, I mean, I think that takes care of like most of the real issues that are facing the PID recycling. Whereas this seems like very much an edge case of apport kind of doing something a little bit hacky by trying to read the file system of, because I don't think we actually mentioned it, but it does read proc/pid like of that process. That's how it's getting some of the extra information that it has when it's crashing. But it's reading that of an already crashed process. It's just kind of lucky that the kernel hasn't already killed it yet. Like it seems like it's kind of a hacky edge case already. That most cases of PID reuse, the PID FD is kind of where you want to go, which is, works for the majority of cases, I'd say.
Yeah, I'd agree. So we'll move into shoutouts. So I have the first shout out here. It's Hardware Hacking Experiments by Jeremy Brun. This is just something I saw floating around. It looks like slides for a talk, but I'm not 100% sure. But just like the way the slides are laid out, it kind of seems reasonable, but I couldn't find the talk. So, I'm not going to say that, with 100% confidence. But it basically goes through the stages they took when hacking a Netgear N300 wireless router. So, doing the recon and looking for photos via the FCC filings, some of the open source intelligence, basically, identifying components for the PCB pictures, probing for UART, dumping the firmware, JTagging it. Overall, just a cool set of slides that gives a glimpse into the hardware hacking world, which I always like to shout out just because it's so, mystical and interesting, and an area that, it doesn't seem like too many people either know much about or just don't really care much about, unfortunately. But, for those who do care about it and do find it fascinating like I do, I think these slides could have some very interesting stuff. Because I know personally, when I've looked at like PCB screenshots and stuff, I've always wondered, how do they actually identify the chips on the board just using like the part numbers and stuff? Like I've tried it before and it's not very easy. And that's where these slides give some insights into stuff like that. So yeah, just wanted to give it a quick shout out for people interested in that kind of stuff. Z, I know you have a few shout outs, which I'll let you get into now.
Yeah, I've got a few. This one actually looks interesting. I didn't get to take a look at it before we started. But mine maybe not quite as much, maybe. I guess you guys can decide. One was just a quick write-up on how I automated McDonald's mobile game to win free iPhones. It's just kind of a fun read, a little bit of network protocol reversing. I mean, there's base 64. It's nothing crazy. Just a fun read with some practical consequences. which is the first shout out that I had. Not much to say there. I just thought it was enjoyable to read, but not something I really want to cover through the podcast. Other thing is a Hyper-V hacking framework. This is from Xerox. Not the company, user. But effectively, you'll have to turn off sign boot, but replace your what's the file name here? Mentions it in here. Either way, boot mgfw.efi. Place that with this one. Reboot, and away you go. And these are just shout outs for you to go look into it a little bit more deeply. Last one is zznop's sploit package, which I thought was interesting. I think I might have even mentioned on one of the podcasts the idea of taking Pwn tools and kind of writing a Go version of it. That's not quite what this is. This is nowhere near feature parity. I don't believe he's even trying to go for feature parity with that. But it's a Go package to aid kind of with the binary analysis and exploitation. So, worth checking out, maybe worth helping out with a bit too. He did leave a comment with a plan to, or at least with some interest in adding in some of the communication stuff that Pwn tools kind of makes really easy, which would be nice to see with Go. Go is maybe not the best CTF language. It kind of feels like a scripting language, but Python's definitely a lot more flexible on that case, for that rapid prototyping. So, maybe not the best choice, but I'm seeing it used a lot more even on CTF stuff. So it's an interesting project to look out for.
Could be a cool project to contribute into if you're looking to do some open source stuff. It's kind of funny because I remember a little while ago there was a discussion in one of the chats I was in that was talking about using Golang for exploits, like implementing exploits in Golang. I'm not entirely sure why you'd want to do that, especially at like the binary level, because obviously Golang doesn't, at least without using packages, you can't directly access like raw pointers or anything like that. So I'm not entirely sure why I love Go, but I don't think I'd use it for exploits. But for people who do, this is there for you, I guess. I'd kind of agree though. If I was doing CTS or something, I'd probably want to pick Python over Go, because the other thing is too with Go, you do have to worry about compile times and fetching the Go module. Although I guess you would have to deal with that with Python too. But yeah, Python in general is just a little bit more flexible and has more of a establishment in the CTF community. There's more stuff for it. Whereas with Go, you're looking at some of these more startup projects like this that won't be close to feature parity. So yeah.
Although Go's definitely getting more adopted for the exploit side of things. And you do have the benefit of performance of just that standalone binary, which in many cases doesn't matter. Like, you're not writing your exploits to be the most performant code out there or anything. Yeah. But Go does still have, it strikes a balance between some of the performance and still kind of feeling a little bit like a scripting language. It's not super like that, but I don't know. I do think it feels a little bit like a scripting language. So I could see the appeal of it. Especially because then you get all the, type checking and all those benefits that you just don't get with Python. I guess you could do annotated Python, so there is the option for it, but...
Yeah, I guess the other thing is, too, there are some useful base packages in Go. Like, with Python, if you want to do, struct packing, you have to use an external module, where with Golang, you have, the binary package and stuff, which has a lot of useful primitives, but... that's neither here nor there. That's just something I thought of when you were saying that.
Yeah, I think Python has the struct package also that's built in.
Is it built in? For some reason, I was thinking it was third party.
Unless they removed it in Python 3. But yeah, there is. If I have to do something that does that, I'm rarely using it. I would use a different language, so...
Yeah.
But yeah, it is built in.
That being said, we'll wrap it up there. That's all the shoutouts we have and all the topics we have. Thanks everyone who tuned in. You can catch the VODs on Twitch or on YouTube 24 hours after the stream. We also have previous podcasts up on Spotify, Apple Podcasts, Google Podcasts, and more links on Anchor. Make sure to join our Discord. Follow us on Twitter if you want to, join the community. We'll be back again next Monday at the same time, 3 p.m. Eastern, 12 p.m. Pacific, with episode 48 of the podcast. And we will see you guys then.